Fifth grade lesson 2.8 is adjusting quotients. Our essential question is, how can you adjust the quotient if your estimate is too high or too low? So this is really where you do get into just regular using the division algorithm, the way you would use it when you've got two-digit divisors. You don't always know because we don't have our multiplication facts memorized, most of us past 10. And because we have those memorized past up to 10, when if it's a one-digit divisor, that's pretty easy. We know the multiplication in our head. But when we're looking at a two-digit divisor, we don't know those in our heads. So we have to experiment with numbers. We estimate to get close, and then we test out that number. And that's really what this is doing, is saying, do an estimate, then test out that number and see, is it too high, is it too low, is it just right? So let's see this in action. When you estimate to decide where to place the first digit, you can also try using the first digit of your estimate to find the first digit of your quotient. And then sometimes our estimate is too low, or it's too high, or it's just right, like the three bear thing. Okay, divide 3,382 divided by 48. They've set us up over here. And we do our estimate, and generally, like they've written this down, but generally this is just something you're doing in your head. If I rounded this to 50, then, and we were doing this in a previous lesson, so if I round that to 50, then I want multiples of 5 with those first two digits. So I'm going to round that to 3,000, which is what they did here, 30 with two zeros on the end, because I know 5 will land on 30 as a multiple. Multiple of 5 would be 30. And I know that 5 times 5 times 6 is 30. So I'm going to put the 30 with the 0 on the end from this, and then one more 0 there. So I know it's going to be about 6 tens. So my goal is that I think 48 times 6 is going to get me pretty close. So my estimate that I would have done in my head, and you'll get fast at this, you'll get better at this, so you don't have to kind of all lay it out. It won't feel so cumbersome and so too many steps C going on. It happens fast in your brain with practice. I know it's going to be around 48 times 6-ish, but I don't know exactly because I had estimate to 50. So that's where I go ahead and off to the side somewhere, I test that out. 48 times 6, that's 8 times 6, 48. 6 times 4, 24, and then 4 more, 28. And I get 288 is which they got here, right? They went ahead and subtracted and noticed that they ended up with 50, which is higher than that. That tells you could have gone more. Even before I do any subtraction to find out and touch my algorithm over here at all, I look at this and go 288. Well, that's close to 338, but I think I can get one more. So I just go ahead and experiment with one higher, 48 times 7 instead. So anytime I'm dividing with two-digit divisors, I have space on my page somewhere where I can do I call it my math lab, and where I could experiment with my different numbers. And if multiplication now for you is probably pretty fast, so it's not that big of a deal. It doesn't take long. 7 times 8, 56. 7 times 4 is 28. Add 5 more, 33. And we can see that that goes in perfectly. So what I have found on this one is that 48 times 7 gives me 336, and they didn't give me room there to continue the process. I'm going to just do it just so you could see the process. We realized 6 was too low. We adjusted, made it a 7 instead. We know that's 336 with 2 left over, and 48 times 0 is going to put me at 22. So I'm going to end up with a remainder of 22. I can make that a fraction. I can reduce that fraction. That's not my focus on this one right now. I want to just get you used to making the adjustments to these. Over here, they said, we have 453 divided by 65. Let's round 65 to 70. Now we're looking at the 7. The 7's multiples. 45 is the numbers I'm looking at on the front here. 7 times 7 is 49, so we can make that 49 with that 0 on the end. And we already have the 0 here to make up for that 0 on the end. So it would be 490 divided by 70 is going to equal 7. But that's if this is the adjusted numbers. Now we still have to test out, okay, that's if it was 70. What's 65 times 7? So we go over to our math lab. 7 times 5 is 35. 7 times 6 is 42, 43, 44, 45. That's just a bit too high. Okay, so then we dial it back one in the lab. 65 times 6, that's 30. 36, 6 times 6 is 36, 37, 38, 39. And so I would get 390 subtract. This is kind of messy here because they didn't give me enough room. I'm just going to fix that. I'm going to do this off to the side because some of you are going to need to see what I'm really doing. Okay, we did times 6 and we got 390. That's 3. We're subtracting. I had to borrow their 63, remainder of 63. And it's super close to that, but it's under that, so I couldn't go any more times. That's as much as I could go. 6 and almost 7, super close to 7, but not quite. All right, so that's all they're showing us here. Kind of get round in your head to see what it should be close to, and then go off to the math lab and make your adjustments. A new music group makes 6,127 copies of its first CD. The group sells 75 copies of the CD at each of its shows. How many shows does it take for the group to sell all of the CDs? What's being split apart? Actually, I'm going to put this on another page so I have, well, maybe I can move this aside. There we go, that's better. Okay, so what's being split apart? I have a total of all these copies of CDs, right? Then I'm sharing them equally amongst how many I sell at each show, and that's 75. So when we are dividing, we take the amount that's being split apart, 6,127 as my dividend, and then I divide it into how many pieces it's being split up, and it's 75 that are being sold each day. So now they do this for us, but let's walk through it anyways. Let's use our estimating to know what we're going to use here. This 75, I can round it, it's right in the middle, so I can round it to 70 or 80. They did it to 70. I probably would have done it to 80. It doesn't matter. You're just trying to get close. So if they're calling this 70, we'll say, okay, well, if that's 70, then I'm looking at multiples of 7 to get to 61. 63 is a multiple of 7. So I'll just go ahead and say, okay, let's call this 6,300. Okay, 7 times what number gets me 63? And 7 times 9 does that. So I end up with the 9. I have this 0 on the end, already taken care of, matching. So I just need one more 0. It'll be 90. Anyways, I'm only looking at this 630. It may be a 9 right here, but I have to test it now because that's if this was 70. It's not, it's 75. I think it's going to be a 9, might be an 8, but at least I'm close. At least I'm not having to guess between 1 and 9. I can guess somewhere closer. So that's what the estimating does for us. 75 in the math lab times 9. We're trying to get 612 or below. So 9 times 5 is 45. 9 times 7 is 63. 66 added with that. That's 665. That's too high. So I guess it's 8. 75 times 8. 7 times 8 is 40. 8 times 7 is 56. Add 4 more, 60. And so that's going to be 600. Can I erase that? No, it won't let me erase it. Or whatever. 600. I get my remainder. That was an 8, not a 9. I knew it was either an 8 or a 9 because of the way I rounded. And again, eventually that happens all in your head. It's going to be 8-ish or a 9-ish. Then I start experimenting. That's all this lesson is about. Okay, bring down. 75 times what number is going to give me close to 127? Again, let's round that to 70. So 7, and then I need a multiple of 7 here. So 140. So 7 times 2 gives me 14. So I'm thinking 75 times 2. Let's experiment with that. That's 10. 2 times 7 is 14, and 1 is 15. That is too high. So I guess it's just going to be 75 times 1. Hopefully you're seeing how I'm making those adjustments. 7, 8, 9, 10, 11, 12, 52. That is smaller than that, so that's as much as I can do, and I end up with a remainder of 52. This means, an estimate that was too high or too low, correct. Our too high one was 9. No, it's not correct. And we adjusted, we made it the 8. We didn't really do the re-estimate, we just calculated and it was just right. It's fine. Oh, this is 100. Oh, this was for this part. Gotcha. That was also too high when we did the 70 times 140, and we did it times 2, and we're like, whoopsie whoops, that's too high for this. That's what they're talking about here. Sorry, I didn't go in their order. I just got excited and went ahead. Okay, adjust the quotient if needed. We did. We made it a 1. So it takes the group 81, it takes them 81 shows to sell most of the CDs, but there's still some CDs left. There's still 52 left. So we're going to have to make that adjustment. How much to sell all of them? It's going to take 82 shows. One of those shows, they're just not selling all of them. So they're selling only 52, not 75. So it'll take 82 shows. We had to make the adjustment for what the answer was. Okay, they say try this. When the difference is equal to or greater than the divisor, the estimate is too low. So, I think you're understanding it. You use an estimate. You decide if it's too high, you adjust. If it's too low, you adjust. And you use multiplication to kind of help you figure that out. Let's look at their example. 336 divided by 48. We would round this to 50, and then we're looking at multiples of 5 on this first number, the first two numbers here, multiples of 5. 30 is a multiple of 5, so it's 35. It's right in between. We'll go with 30, so let's call that 30 with a 0 on the end, 300. That's what they did here, 300 divided by 50. And we know that 5 times 6 is 30, so that's what we're going to get there. So let's do that. We're going to do estimate. With our estimate, we're going to try 6 ones to see what 48 is, though. So we have to do that. This estimate was with 50. Now we have to check that 6 with the 48, with the actual amount. That's why we go to the math lab, because we know about how much we expect it to be, but we're not sure because this is not 50, this is 48. So we have to math lab that. 6 times 8 is 48. 6 times 4 is 24. Add 4 more, 28. It fits, but remember our goal is to get as close as possible to this number, and it might be, this might be too low. So just go one up then, 48 times 7. 48 times 7 is the adjustment we'll make. Try 7. This is 56. 7 times 4 is 28. 29, 30, 31, 32, 33, and that's perfect. That's exactly right. And here, since 6, I'm not sure what they exactly want there, but since 6, the estimate of 6, I guess, is too low, then 336 divided by 48 is, we'll try 7, and that's what we tried. We got that, and there we got it. So I don't know, I'm not exactly sure what they want me to write there, but anyways, the process is they want you to use your estimating and your rounding to just hone in on about how much. So you don't have to multiply, oh, let me try 48 times 2. Nope. Let me try 48 times 3. Nope. Let me try 48 times 4. Nope. Let me try 48 times 5. Nope. Right? That would take you a very long time. If we get really quick at rounding those numbers to get honed in on closer to where we know it's going to be, then we only had to do 48 times 6. Nope. 48 times 7. Yep. Okay, on these first set of problems on the share and show, they did their estimate, they got a number, and they haven't tested it in the math lab to see if it's correct or not, and so we're expected to go ahead and adjust and then finish dividing. So let's go ahead and take a look at what we've got here. We'll go through the steps like you're going to go through the steps with these, like I would go through the steps with these, so that we can get used to the process. This is, I would round this to 40. And if this is a 4, then multiples of 4, looking at these first two numbers, 15 is really close to 16, and 16 is a multiple of 4. So 4 times 4 gives me 16. If you need to see that. Again, that all happens in your head usually. I already rounded this to 40, and so I'm looking at this next number, the 2 digits, and I want that to be a multiple of 4. So 4, 8, 12, 16, that's as close as I'm getting. So I'm going to call that 40 times 1600, and that's going to give me a 4 here because of the 0 on the end, right? And that's what they've put there. So they did that rounding. I did it in my head, but I also did it visually for those of you who are still not sure what I'm talking about. Hopefully that helps. We think it's going to be 4. I tend not to write it there until I have gone in and experimented in my math lab. So I'm going to do that. 41 times 4. 4 times 1 is 4. And 4 times 4 is 16. I get 164. 164, and my goal was 154, so that's too high. So I won't use that, and that's why I wouldn't have written that there. I'm going to use a 3 instead. So 41 times 3 then. I knew it was 4, maybe 3, and so now I just need to do this one. 3 times 1 is 3, 3 times 4 is 12. So this is 123. This should be a 3, so right over the top of where they wrote 4, adjust to a 3. Find out what's left. This is 3, and bring down. Now again, this happens fast. I need a multiple of 4 that's close to 31. 32 is close to that, 320. 4 times 8 is 320. Let's test that. 41 times 8. I think it's going to be too high. It's 328. So we adjust. 41 times 7 then. That's 7 and 28. So 7 is 287. 7 minus 16, or 16 minus 7, sorry, is 9. Borrow again. We get 2. So we get a remainder of 29. So 37 with a remainder of 29 is the answer to that one. I'm hoping as we practice through these and you hear me think it aloud, you're starting to see what they're trying to get you to do. Okay, I'm going to round 16 up to 20. And so that gives me the 2 that I'm looking for multiple of, 20, the 2, and 20. I'm going to round that to 40 because 2 times 2 gives me 4. So that's why they've put the 2 up here saying, I think it's going to be that. But let's test it. Let's do 16 times 2 to see if that is, in fact, going to be a 2 here. 2 times 6 is 12. 2 times 1 is 2, and 3. That's 32, and I'm getting to 41. It's only 9 away, not 16 away. So that's as many as I can fit. So that's correct. 16 times 2 is 32. Subtraction. Okay. Now, again, rounded to 20. So I've got the 2. I'm going to round that up to 100. So I'm looking at the 10. 2, 4, 6, 8, 10. 5-ish times. 16 times 5 is my experiment. 5, 6, 7, 8. I think I can go one more time. So let's go up 1. 16 times 6. 6 times 6 is 36. 6 times 1 is 6, 7, 8, 9, exactly 96. So 16 times 6 gives me exactly 96. I hope I didn't go I may have gone too fast on that one. I'm sorry if I did. I'll see if I can slow this down for those of you who aren't sure what I'm doing. Some of you I know are getting it. Okay, 34. I'm going to round that to 30, and I'm going to use that 3. And I'm thinking of all my multiples of 3. Now I'm looking at 28. And 28 happens to be a multiple of 3 because 7 times, no, it isn't, sorry. 27 is a multiple of 3 because 9 times 3 is 27. So I'm going to think of this as 2700. That's what I've done in my head, right? And I know that 3 times 9 is 27. So using this basic fact, I'm going to experiment with this 9. 34 times 9, what is it? Will it be close to 283? Will it be too high? Will it be too low? So I'm going to test it with the 34 because I had rounded to 30. I have to know for sure the amount. So 9 times 4 is 36. 9 times 3 is 27, 28, 29, 30. And look, 306 is too high. I need it to be 283 or lower. So it's not 9, but I knew it was going to be close to 9 because of my estimate, so I just do the one just under that, 34 times 8. 8 times 4 is 32. 8 times 3 is 24, 25, 26, 27. 272 fits, right? So it's not 9, it's going to be 8 instead. Again, I do my rounding, and before I ever write a number up here like they did, I go to my math lab and experiment with the number that I know it's close to. Then I write my number up there. Subtract to find your leftover. And now I do that one more time. I'm rounding that to 30, so I'm looking at the 3, close to 111. Well, 3, 6, 9, 12. I'm going to round it down to 90. So 3 times 3 is going to give me 9. So I'm going to try 34 times 3. So 34 times 3. 3 times 4 is 12. 3 times 3 is 9, plus 1 is 10. That's going to fit, and I can't add another 34 to that and stay under 111. So I'm using the 3 for 102. And I will have a remainder of 8. 83, remainder 8. Practicing a few more. I mean, if you get it and you know what we're shooting for, you can go to Think Central. If you're feeling like, let me just see a few more, let's do that. Okay, a few more, hoping that you get the hang of this. I'll round 19 to 20. And since I rounded it to 20, that will be a 2. Think of your multiples of 2. And looking at this first number, 91, a multiple of 2 that's close to 9 is either 8 or 10. Let's go with 10. So let's say we know that 2 times 5 is 10, right? So let's test out then what 19 times 5 is. 19 times 5. 9 times 5 is 45. 5 times 1 is 5, 6, 7, 8, 9. Ooh, and it's a little too high. I needed 91. I ended up with 95. So what do I do if 5's too high? It's close. I go down just by 1. 19 times 4. 4 times 9 is 36. 4 times 1 is 4. 5, 6, 7. And that's what it's going to be here. So 4 goes here. 76 goes here. Subtract for leftovers. We get 5 and 1. Double check, make sure this is smaller than your divisor, and it is. Because if it wasn't, we could have gone again. We knew we couldn't, though. All right, again, we rounded this to 20, so thinking of your multiples of 2, that's close to 15. 16, let's go with 16. 2 times 8 is 16, so let's test out the 8 with 19. 19 times 8. 8 times 9 is 72. 8 times 1 is 8. 9, 10, 11, 12, 13, 14, 15. Yes, that works perfectly. 8 goes here. 152 goes here with a remainder of 3. I'm hoping this is starting to fall into place. I'm hoping I'm not confusing you. Let's try another. 28, let's round that to 30. 28 is close to 30. Now that we've got that rounded to 30 in our head, we're looking at the 3 and 30, and we're thinking of all of our multiples of 3. Thinking of those multiples of 3, what is close to 18 that 3 will land on? Actually, 3 lands right on 18, right? 3, 6, 9, 12, 18. 3, 6, 9, 12, 18. So it's 3 times 6 is 18. So we're going to experiment with that 28 times a 6, because we know this answer should be somewhat close to that. 28 times 6. 6 times 8 is 48. 6 times 2 is 12. 13, 14, 15, 16. Okay, 168 and 182. It fits. I don't think I can fit another 28, but I'm not entirely positive. So I'll go ahead and experiment with one higher than that, 28 times 7, just to check. 8 times 7 is 56. 7 times 2 is 14. 15, 16, 17, 18, 19. Yes, that's too high. So we're going to use this one, the 6. And I put it over that 182 because it's 168. I got to fit under that. 168. Subtract for what's left. That's 4, and 7 minus 6 is 1. Double check. Is that smaller than your divisor? Yes, it is. Now bring down. Okay. Again, we'll round that to 30. Thinking of 3, a multiple of 3, that's close to 14. 3 times 5 is 15. So let's try 28 times 5. 8 times 5 is 40. 5 times 2 is 10, 11, 12, 13, 14. Ooh, yeah, that was really, really, really close. And there's no way I'm fitting another 28 and staying under 145. So that is what it's going to be. 28 times 5 is 140 with a remainder of 5. One more. I hope one more is all you need, but if it's not, you can come find me and see if I can help you out with it with a few more. 45, I'm going to round that to 50. And since I've rounded that to 50, I'm thinking of the 5 in the front of 50 and all of its multiples. And 35 is a multiple of 5. So I'm going to use, 5 times 7 is what gives me 35. So I'm going to use 45 times 7 to see what I get. 7 times 5 is 35. 7 times 4 is 28, 29, 30, 31. That fits. I'm pretty sure another one won't fit though, but let's try 45 times 8 just to make sure. Remember, our goal always to get as close as possible. 8 times 5 is 40. 8 times 4 is 32, 33, 34, 35, 36. Yeah, that is just a bit too high. We're going to use that 7. We don't have to calculate it again because it's sitting there in our math lab nice and happy. Let's subtract for our remainder. 11 minus 5 is 6. 4 minus 1 is 3. And bring down. Okay, here's why I like leaving things alone in my math lab, because I know 45 times 8 is 360, and that's what's going to give me my answer here. So sometimes your answer shows up there because you were calculating for something else, and this time it did. I don't even have to guess. I don't have to look. It's 8, 360, and I will have 8 left over. There we go. I hope that this makes sense to you, that this whole lesson is just that you're using the same algorithm as always, but use your rounding skills to focus in on the numbers so that you don't have to be guessing all over between 1 through 9. You can focus in, and now you only have to do maybe 2 calculations rather than 5 of them. So that's what this lesson is helping you do. I hope that makes sense to you, and I hope you have success on Think Central. Good luck.